All right. So hello everyone. My name is Miriam Cristofoletti. I am an electronic engineer at Renishaw, and today I'm going to tell you a bit about how I got, my journey into engineering, and also why I love it so much. Okay. So a bit of a background. As you can guess from my surname, I come from Italy, where I was raised and born and raised. Sorry. And in a little city near the Garda Lake. It was great because almost every weekend we used to go to the lake and have some family time. It was amazing. I spent there most of my life, and then roughly 5 years ago I moved to the UK, first to Exeter and then to Bristol, two amazing cities that I always feel like I'm at home. And this is me. In all these pictures, I was about between 6 and 9 years old. I was a very active girl, a lot into sports. I used to do gymnastics and rollerblading and swimming as well at a competitive level. Also at home, I was always busy doing something like crafting, building things with Lego, carton board, whatever. Even though I was quite good with numbers and science in general at school, I never thought about myself becoming an engineer. I actually didn't even know what an engineer was. But what I wanted to do was to invent things. I was very creative and I wanted to become an inventor. But then with the years, you learn that not everyone agrees with you. Not everyone supports your decisions, your choices in life. And I'm thankful that my family, my parents, they always supported me, but other people around, they were not that supportive. And so you can find people around you that will try and stop you, break your dreams and things like that. But you should be strong. And here comes one of my favorite quotes from The Pursuit of Happiness. Will Smith says, "Don't ever let someone tell you that you can't do something. You got a dream, you have to protect it." And when people don't know how to do something themselves, they're going to tell you that you can't do it. And this is so true. In fact, when I started to grow up and I had to decide my secondary school, I wanted to go to a science and technology secondary school. But I clearly remembering people telling me things like, it's a boys' school and you're a girl, you can't do it." And my maths teacher, she once, I remember her laughing at me because I made a mistake in a calculation once, and she went like, "You can't even do multiplications." And I was really sad. I got really hurt in my heart. And but I thought about it, and I stood up thinking, I don't care what others say. And I applied to that very school. And yes, it was a class with like more than 20 boys and only 3-4 girls maximum. And plus I was the only Muslim girl in the entire school. But I loved it. I enjoyed my time with my classmates. I built strong knowledge of science and technology, and I ended up with a first. Then again, some nasty comments and skepticism came across when I wanted to apply for university for an engineering degree, and also when I wanted to go abroad. Why going that far? You won't make it. Girls don't do that. You won't like it. It's a man thing. Anyway, I couldn't care less. I wanted to do something, and I wanted to pursue my dreams. Okay, I studied materials and nanotechnology back in Italy, and then I moved to the UK. After working a bit and learning some English, I started robotics at UE. So in my degree at UE, we learned to build robots from the very, very first day, from the very, very first year, actually. So here there are some videos of projects we've done across the 3 years. You see like a robotic arm moving objects around. This is a mobile robot following a line with some sensors. It's made with some Lego parts. And then these are little clips about another project, always a mobile robot, but it was trying to move around in a maze, find the center, and find the quickest route to the center. And yeah, as you can see, none of these projects work the first time, okay? The first attempt never works, but then it really takes effort and persistence. Another great experience at uni was being part of the Bristol Robotics laboratory. Here I did 2 summer placement, like internships, and also I worked there when I was working on my dissertation project. You have to imagine it as a massive multidisciplinary laboratory, okay, with very, very cool stuff in there. We have robots looking like humans. We have robots with whiskers like cats or rats like this one. We have self-driving cars. We have drones. We have a massive arena with drones. Many, many little collaborative robots working together like bees or ants. And then we've got Pepper, this one over here. It's my favorite. It's a lovely humanoid robot used as a companion for elderly people. And it can also dance, as you can see. It was showing off in an event once. This one is another robot. It's called Neo. It's from the same company as Pepper. But look at the way it stands up. It's not controlled by anyone, okay? It just does it by itself. It's incredible. I find it so fascinating. And then it sits back again. This one is the MekaCup. So basically, a group of friends and I joined a robot competition. It was organized by a company in Bristol called Robotics. They provided us with this spider-like robot, and then we had to modify it and make some changes to run it for in a like a rescue environment for rescue missions. Okay. As you can see here, we put the camera, and these were like the snaps, the videos coming from the camera. Sadly, then the competition was cancelled, but we really enjoyed our time to design and build everything. So it was really fun. Then, you know, like during your last year at university, you learn, every student has to do a research project. So my project was about a robotic arm learning from a human through a camera how to manipulate objects. So here you can see there are a few initial tests when I was trying to recognize the basket and give the distance from the camera in millimeters. And here it's another test is trying to the system is trying to detect my the joint of my arm, of my hand. Here are the other tests trying to determine the distance with just one camera, you know, like all the dimensions, and also another test to try and recognize my hand, the movement that it was doing, whether it's open, closed, whether it was lifting up or down, left and right, and everything is done through a camera. Another test here, actually other 2 tests, they, like little by little, I managed to recognize the objects, so boxes and cans, and also the way my hand was holding them, so whether from the top or from the side, and the direction as well. It was really fun. Eventually, finally, I managed to put everything together, and I had the system recognizing the objects on the table and moving them first outside the basket, and then placing them on a side table. Sometimes it gets stuck in some positions, yeah, like now, but what I have to do is to home the robotic arm again and move the object slightly and run it again. And this is what engineering is all about, really: creating, testing, building, trying again, fixing things, and never ever give up. So then at the end, it just so happened that I graduated, and I went to work for a company called Renishaw in an engineering and manufacturing company in Gloucestershire, and I was as a robotics, as an electronics engineer. So here you can see some of the products that our company is building, mainly measurement and precision objects product. I actually worked for Renishaw before. Between my second and third year, I went for a year in industry, and I was in the laser and calibration division. I worked on 2 test rigs to assess and check the operation of 2 different machines. It was a really, really good experience because I got to see how a professional engineering environment really looked like. And I also developed my practical skills, and just because I designed and built all these 2 boards myself. Then after graduation, a few months ago, like last summer, I started working in the encoder division. Here there's a picture of my bench at work. It's a bit messy, I know, but it has everything I need. So just so you understand what encoders are, I'll give you a bit of a background. A position encoder is a tiny device, okay, used to measure a position. It translates the movement into an electrical signal. Typically consists in 2 parts. So we have the read head, sensing and processing the signals, and then a scale, okay? You can imagine it as a school ruler, okay? Used as a reference for the measurements. Encoders can be linear or rotary and can be applied to anything around us, really. Literally anything. You need precise and accurate movements in machines and robots used in all these sectors. So you have health, space, energy, mobile services, communications, transport, anything. And to be honest, this is what I like, because technology in general can be applied to anything you want. Anything you like, you can apply engineering and technology to that. So where do I get my inspiration? So in many places, really, mostly from sci-fi movies and cartoons. Since I was a child, I've always watched kind of futuristic stories and series. Most recently, Marvel is one of my favorites. And but what you should understand is everything here is amazing. When I was little, I was watching these movies and saying, I want to be like that. I want to build that. I want to invent that. But the reality is that there are also some amazing people, real people, okay, around us you can take inspiration from. For example, the father of SpaceX and many other companies, Tesla and stuff, Elon Musk, for example. I knew some people criticize him for loads of many different reasons, but what I like is his strength, his determination. Whenever everything seems over and destroyed or whatever, he gets up and says, whatever, let's try again. And also Google founders, Sergey Brin and Larry Page, the incredible job they did in giving us the most powerful online tool and other things, you know. And also, for example, Steve Jobs, who really created the era we are here now, we are in now. And I can add Microsoft Bill Gates, Amazon Jeff Bezos, and many more businessmen that literally started from a garage. Can you imagine it? And then built all the way up. But we also have to think about other people hidden from all the cameras, hidden from all the pictures and all the lights, who did an incredible job so much before these guys. Okay, for example, Mary Jackson, Catherine Johnson, and Dorothy Vaughan. They were the first. Black female engineers in NASA. They've done an incredible job for NASA. It was brilliant. Them and other women as well. If these women didn't, and others like them, didn't do what they did, Elon Musk wouldn't have been able to send his rockets to Mars. And another example is Karen Spark-Jones. She's a computer scientist who put the foundation of search engines. So for example, like Google, okay? If she didn't do what she did, all her research, all her work, we wouldn't be able to just Google things on internet. And of course, Ada Lovelace, famous for her work on the very first computer in history. If she didn't do what she did, all the effort, none of these guys, none of them would have been able to do anything. And the world today would be very, very different place. I mean, I think all this is remarkable. It's impressive, but it does take hard work. Because everyone, if you imagine like an iceberg, okay, everyone sees the success of great people just looking at what they have achieved. But the reality is that there's much more behind the scenes. What you don't see is all the persistence or the dedications these great people had, the many failures, sacrifices. These great people have done, they've passed through bad phases in their life, okay? The disappointment, the discipline, the hard work. They actually started from nothing but an idea, spent a lot of time trying and trying and trying and trying, and then the reward for their hard work came. And it always comes, believe me. Like for us as well. If you have a good idea, you want to change the world, okay? Don't wait until you find the perfect role model to follow, or until you find everyone around you that will say, oh, well done, great, that's a good idea, just carry on. It's really, really hard to find. But you can be your own role model. You have to think about it as taking inspiration from here and there, but also be the first, okay? If I was to wait to find a person that would match exactly my aspiration, identity, background, everything, I would still be there looking, really. Like it has to be a woman, Muslim, engineer, Italian, many things. But what I've always done is simply thinking, who do I want to see in the mirror in 3, 5, 10, 20 years, okay? And this could be you too. Whatever is your passion, your interest, you just never ever give up. Be the first one. And if something goes wrong, just don't worry. Just don't worry. It's just, you have to think about it as just the very first step of the ladder, okay? One of the hidden things inside the house, underneath the water, in the iceberg. One day you're gonna change the world, and I'm gonna hear you telling me your story about your first failures and sacrifices, but also the success and the achievement that you have. It's amazing, and I will hear you. At UWE, we had something called Women in Science and Engineering. It's a society where some friends and I formed a couple of years ago to promote and support STEM subjects. So we do trips, conferences, talks, and other activities with the support of the engineering department. And so when I was at uni, we took part in an exciting project. It was about building the design of one of the Leaders Award winners. We chose Philippa Griffith's RLBS. So basically it was a red line braking system. It was a car graded backlight, changing depending on how hard you press on the brake. Here's a picture of the team, and this is Philippa design. We started with very, very simple experiments. As you can see, just pressing on a sensor and the LEDs will lit up. And we also had our first prototype. Whenever we pressed the pedal, the lights would turn on. And we also went to visit Philippa in her school. It was really good fun. We wanted to make sure that she was happy with what we were doing and to keep her updated. Also, we prepared a little workshop for her classmates to understand the principles of what we were doing, and they enjoyed working on electronics and software very much. Finally, for the actual project, we bought a Mercedes, and we started pulling it apart and add all our stuff. the braking pedals, the backlights, circuitries, many other things. It was really, really fun. And we kept on trying and trying and trying until we eventually got it working. Whoops, we eventually got it working, both the pedals and the lights, as you can see. It was a really good feeling whenever you start it up and say, oh, it works, it's amazing. So for the Leaders Award ceremony at UE, we presented in front of the New Year's winners, the competition organizers, the supporters, and distinguished guests. The Minister for Universities, Science and Research and Innovation, Chris Kidmer, the UE Bristol Vice Chancellor, Steve West, and the MOD Air Marshal, Julian Young. It was really, really good event, and we enjoyed so much. We actually enjoyed the whole project very much. So my message to you today is, don't be afraid, be the first. Nothing works well the first time, and that's fine. Just don't worry, don't panic, okay? Have a good team to work with. There's more fun together as anyway. Do your research well, and hang on. Yeah, do your research well, discover and learn new things. It's always good to learn more, right? Dream big and work hard, because it's worth. At the end, you will have you will be very happy about what you've done. Share ideas and don't be shy to seek help. Sometimes we are a bit shy. Oh, I don't know whether I'm gonna ask that. Oh, maybe it's a silly question. There's no such a thing as a silly question. Everyone says that, okay? Just don't worry. And never, ever, ever give up. Okay, this is the very, very important thing. And actually, there's one more important thing. Enjoy yourself, because you are an amazing engineer. Take part in this amazing competition and come up with a great idea, because next year it could be your design that's going to be inspiring some other engineers to build it. Okay? Thank you.
Brilliant. Thank you, Miriam.
Thank you.
Wonderful. Okay, schools. If anyone has any pupils have any questions, I think there's one there already. Could you please type them into the chat facility, and Miriam will read them out and give her answers. Yeah, there's. Did you aspire to be anything else? Oh, here we go.
Yeah. Where's the chat? I can't find the chat. Just a second. Should I stop sharing the screen?
If you come, yeah, come.
Yeah.
And then go to the bottom. You'll see the chat.
Yeah, there it is. All right. So, did you aspire to be anything else? Right. Not really. Well, as I said, I didn't want to become, when I was little, I didn't want to become an engineer, because I didn't even know what that was. But I wanted to invent things, okay? I wanted to create things. I think that's always been my my idea, my dream. Actually, at some point I wanted to become a doctor as well. Yeah, but it didn't happen. So we have aspiration day today. That is why we are dressed up. Ah, hello. That's really, really nice. What is your latest invention? Right, my latest invention. I'm actually working at work at a new product. It's a secret, so don't tell anyone. It's another kind of encoder. So that would be the latest one. But it's a very teamwork effort, so it's not just me. Okay. Do you enjoy making robots? Oh wow, yes I do, so much so. Sometimes, as I say, sometimes things don't work, or don't work immediately, right? But that's not an issue. You are a bit upset in that specific moment, but just chill. You'll get over, and everything will be fine, and you'll find why why that thing doesn't work, and you'll fix it. And then next time you'll find another problem similar, you've already got your experience from before, so you will know it straight away how to solve it. How hard is to be an engineer? It's not hard at all. It's so fun. I understand sometimes people, they get a bit put off when you start studying engineering, or when you start studying maths, or whatever you like, you know, the path. Okay. But it's not. It just takes a bit of effort. Okay, a bit of you have to work hard. Okay, that's something that I can't tell you that's not true, but that's with many other things. If you want to achieve the top, you really have to put an effort and find a way how to enjoy your time while you're doing your work. Okay, that's the main thing. Never ever do something that you're not enjoying. Like, sometimes you have to, right? Of course, but dreaming like your dream job or whatever, it has to be something you're really passionate about. Okay, that's really key. So you don't get bored when you're at work. You're having fun, times pass quickly, and you're happy. Where do you get robot parts from? Okay, you get them online mainly. So for example, motors or other components inside circuitry or microprocessors, you get everything online. There are quite good websites. I don't know if you want something specific, I can tell you. There's the Funnel and what's the other called? RS. They are website where you just, it's like Amazon. Okay, you just go, and sometimes you can also get stuff from Amazon, really, and you just look for whatever you want and you buy stuff. How old were you when you wanted to become an engineer? Right. So to become an inventor, I was quite young. I was probably in primary school. Yeah, primary school, the end of primary school, roughly. But actually, engineer, I was a bit growing up. I was in secondary school, the end of secondary school. I really decided, yes, that's what I want to do. How many years have you been an engineer? My whole life. No, okay. So this is something that it actually came up in one of the seminar that I attended. People say, how long have you been an engineer for? And that people would think is just when you are like, you have a title of, for example, in my case, electronic engineer. So in that case, I've been an electronic engineer just a few months, right? Or maybe just when you started studying engineering. So in that case would be robotics engineer, and that would be 3 years of my study. Okay, actually 4 years. But in reality, you are an engineer even now. Okay, even in primary school, if you enjoy building things, if you enjoy problem solving, if you enjoy thinking, how would that work? How does that, if you open up a toy or something, that's really how things work, how you are an engineer already. You haven't started studying engineering yet, and you're not an engineer like with your desk in a company yet, but you're already an engineer. Do you like being an engineer and scientist? Yeah, I do so much. I love it. It's I don't know if I would be able to be something else. It's really, yeah. What's the best tool to use? It depends what you want to do. But I think a computer is like the best tool you can use, you can start with, because of course you you can do many things in there, and it helps a lot. Is your job difficult? And well, no, is your job difficult? No, my job is not difficult. As I said, it takes effort, it takes hard work, But since you enjoy what you're doing, since you're passionate about what you're doing, it's not difficult. Sometimes you get stuck, that's fine. But then, like, for example, in my case, okay, if I'm stuck in something that I can't carry on with, or it's not behaving the way it should, right? I try first and see whether I can solve it myself. And then I look up online if someone else has already had a similar problem and has posted maybe a solution. If not, then I turn my chair and ask my manager. He's sat next to me, like, how can I solve this? How can I do this? Or even when I'm not stuck, I can just ask him, how would you do this? Would it be better do this or better do that? What would be, like, you can seek help everywhere around you, from your colleagues, from your friends, from your classmates, from your teacher, from your manager, in my case, okay, anything. What's the best, worst part of your job? Oh no, I missed one. What materials do you use? Yeah, I said, oh, materials, right? The materials you use to make a robot, you can use anything you want, really. I saw robots like with paper. I saw robots with rubber. It depends. It literally depends on what you want the robot to do and where you want the robot to be. Let's say you want to build a robot able to go underwater. You won't be able to use wood. You won't be able to use paper. You won't be able to use, you need materials that are impermeable. They or like maybe you have an enclosure, plastic or whatever. Or if you want a robot to be able to fly, you can't do like metal or really heavy materials, because then it won't be able to fly. It depends on what the applications are. What's the best and worst part of your job? So the best part and the worst part. The worst part, I think, is when you don't when you don't know how to carry on. Okay, maybe, yeah, I would say that is when you don't know what's your next step, when you don't know, maybe because you planned bad, because the good practice says that before starting a project you have to plan all the way down, like how all the steps are placed, okay? And that could be the reason why you didn't plan well, and then at some point you're stuck. Or another bad thing that could happen is when you don't get how to say it? You don't get, for example, if you're working in a company and you have a great idea and you want to have, like, do something different in a project or something or whatever, there are some people above you, like in other levels, okay, that maybe they will say, no, we don't need this, or we don't have money to fund this, or we don't have time to do this. And that is a bit frustrating sometimes, because it's not up to you. Unfortunately, sometimes you have to just follow the rules and say, oh well. But never, this is actually important, whatever idea you came up, if someone else that is like in charge will say, no, we will not look at your idea or whatever, you don't just discard it, you don't just dispose it, you don't just delete it from your mind. You keep it somewhere, okay, in your mind, in your notebook, in your whatever. You keep your idea, okay? You can have like a notebook full of ideas. I do have something like that. You keep track of your ideas, okay? Maybe in the future something in the environment where you're working will change, and then you can refer back to your ideas and say, I've got this idea, it's been in my drawer since, I don't know, long time ago, and now I can do it, okay? You never know when you will be able to do that. And the best part is when you see the end results, when you see the end product, and you see all your effort for months or weeks or years. It depends on what you're doing, and then it works, and then that is the best, I think. Can you make robots to help people who are paralyzed? This is a beautiful idea. This is really, really important. In fact, that what I was doing for my dissertation project, do you remember the arm that was picking up objects and stuff? It was meant to be in a house of a person, either an elderly person unable to move properly in the house, or a person, a young person, like with some physical disabilities, okay, physically unable to move objects around. So what I was thinking, maybe imagine if the delivery guy arrives with their shopping basket, and they will put the object on the table, for example, and then there's this robotic arm able to pick all the objects and store them in your cupboard or wherever. And that would be a solution for some people unable to move themselves around their houses. Do you make anything else instead of robots? Like any other hobbies? I like learning languages. That's something that I really like, and I really encourage other people to do, because you never know when it comes handy, when you need it. And it's really it opens your mind really when you learn a new language. It's quite and it's interesting. You can learn, when you learn a language, you also learn a bit of the culture in that language, or from that country where the language belongs to. So it's quite interesting. How difficult it is for girls to do engineering? This is a very good question, actually, because it's not difficult because you're a girl, okay? It's difficult because you think it's difficult because you're a girl. This is really important. I felt it myself sometimes. So girls are more inclined to think that they won't be able to. They are not good enough. But this is not true. You are good, and you are good enough, and you are really, really good, okay? This is something that you have to understand. I had a friend of mine, he used to teach in a secondary school, and he used to tell me girls would go to him saying, like, I'm not really good at maths, so I don't know whether I can do engineering or something. And he was going crazy. She, for example, in this case, this girl, she was the best in maths, and she was the best in her class. And why in the world would she think she was not good enough to go to engineering? This is something that we have, and I don't know whether it's just girls or boys and girls, it doesn't matter. Inside yourself, you have to think that you are good enough to do anything you want, okay? If you really want it, okay, then you're good enough. That's enough to be good enough, okay? You have to think that if you really want something, you just go start following that track, that path, okay? And don't care about anyone else, really. You have to, so this is important actually, you have to listen to others' opinion, okay? Because it's important, okay? Maybe they will say something that you didn't know, but only if these opinions, or only if these advices are constructive, that they will add some value to you, okay? If it's something that you didn't know, then, oh wow, I didn't know that, and then you learn something new. Or sometimes it's something about your personality and you didn't realize you are in a certain way or something, then you can pick up things. But just random comments that they are just made to destroy your confidence and destroy your dreams, or destroy, just that, put aside, okay? Just don't listen to these. These are really bad, okay? So yeah, this is my advice to you. How do you make robots? Well, you make robots in a quite long process. You first start with a design, which is part of the competition as well. The very first thing is to find a problem in society. Okay, you find why you want to build a robot. Okay, and then you literally draw. I like doing that. I've got a pad. I just draw and how your robot would work and how it would look like, things like that. And then you start going a bit deeper how this part of the robot would work, and you start thinking, oh, what do I need? I would need this, like doing a list. And then you start, it depends on what your robot does. Okay, then you can start building a prototype, or you can start testing some parts of the circuitry. You can start programming, you can start buying some components or whatever you need, and then you put everything together and test everything. How did you get into robots? Well, as I said before, it was just mainly looking at other people, what they're doing, or movies. I like Marvel's movies. I like Iron Man. That's my favorite. Okay, and I like looking at this guy building and doing. I'm like, I want to be like that. I want to do that, and you just start like that. Did you always want to be an engineer? Well, not always. I wanted, as I said before, I wanted to become an inventor. At some point, I wanted to be a doctor. Actually, when I was very, very little, probably I wanted to be the ice cream man, but that's something else. Right. Where are we? What was the first invention you made? Well, the first invention, I think so. The first robotic invention, the first robotic thing that I built, it was at university. But if you think about, an invention could be literally anything, right? So when I was little, I used to like building things, and for me, anything that I haven't done it before, for me is new, for me is an invention, right? So for example, once I found a frog in the garden, and I was so happy about this frog in the garden, and I took a shoes box, and I started cutting and building, and I literally done like a little house with a door and the windows for this frog. In my head, I was building a house for this frog. Obviously, the frog just jumped in and jumped back out, but that's another story. Thank you so much. We love this. Thank you for listening. What is your favorite robot? Oh, my favorite robot is Pepper. Do you remember the white humanoid robot that I showed you before? That is my favorite. It's a really, really cool because you can program it to reply to you, or to move around, and it's really, really nice. I like that. What subject at school will help you to become an engineer? This is a good question. So you need, well, I think the first thing is maths. Okay, but it's not actually. Yeah, no, that it is. So maths, okay, first. I would say physics. I would say, depending on what kind of engineer you want to become, you could add chemistry or biology, maybe like a medical engineer, a biomedical engineer. So biology is quite important. Or maybe chemical engineers, so chemistry is quite good, or materials engineer, so chemistry also for that is important. I don't know if you have the choice, the options of, for example, electronics, programming, computer science. Computer science, I would suggest it to everyone, because learn, or maybe if you don't want to study in school, you should do it at home, or like in your spare time. Knowing how to program, I think nowadays is really, really important. And like, you're still little, okay, but by the time you get to work, knowing how to program in like, and having the experience of years, imagine you start now, okay, in like 10 years time, you've got 10 years of experience of learning and knowing how to program. You're gonna be a pro. Like I'm not a pro, but you will be. So it's really, really important to be always ahead of other people as well. If you learn to program now, because in the future, I mean, knowing how to program it would be like a very basic thing, I think. What do you enjoy doing in your free time? So yeah, I like learning languages, and sometimes I also like drawing. I do like calligraphy things. Yeah, so these are two things that I like doing. I always get lost which question. Hang on. How long does it take to make a robot? Right. It depends. I know I have this answer, it depends on many questions, but it's true. So it depends, because you can, for example, it depends on how many people are working on this robots project, okay? So if it's just you, it's going to take a while. If it's a group of 4, 6 people, that's going to cut the times a lot, okay? So each one would be in charge of a bit, okay? For example, one of the videos that I showed you about a robot that was running in a maze, the mobile robot, we were 4 people, and so I was in charge of electronics. Another guy was in charge of sensors, another guy was in charge, and actually the other 2, they were doing programming, so software. So it was a teamwork. And it took us roughly not a year, but like an academic year, so basically 8 months, roughly, something like that, 6-8 months. But then again, we were not just doing that, we were also studying other things. Some people, they were working as well. So it depends on what you're doing. If you're only working on that project that you want to build, on that robot that you want to build, of course, it will take less than if you are doing other things as well. So it could take, but typically is a couple of months or even more. Like, I don't think less than 2 months. Okay, that's, yeah. How many robots have you made? All the ones at university, so the ones that I showed you. For example, I didn't make the robotic arm. I didn't build it, but I programmed it and I set it up together with a camera and my computer to be like a system. Okay, so sometimes you don't physically build a robot, but you build the system. So you buy components, like in my case, it was a robotic arm and a camera and other things. You buy them, but they are single, like they are individual bits and bobs like around. But what you do is you build a system. So you put them all together and you connect them and you program them to be talking to each other and send signals or send informations and things like that. So that's sometimes something else that you can do. Do you use a lot of math in your role? Yes, I do. I mean, you mean my role in my job. So, but at university as well, you do that as well. So yeah, you always rely on maths. Anything you need, even with like very easy, let's say, things like just if you need to understand some data that you collected and you want to put them all in a spreadsheet, you need to know how to use maths in Excel and know how to put everything in order for you to understand and have everything in a graph, for example, or having you maybe want to calculate an average, or maybe you want to calculate I don't know, other statistical with other statistical tools that you might need to understand the whole thing. So maths is quite key. But it's good maths, okay? Math is a friend because you can't get it wrong. If you get it wrong, it's because you made a mistake, and that's fine, you can solve it. But it's not something subjective, okay? It's not something that you, like writing an essay or whatever, then someone would say, oh, in my opinion is this or that. There's no opinion in maths. It's 1 + 1 is 2. That's, you just have to learn and put some effort to learn all the rules, all the tools and everything, and that will help you a lot. Can you still make robots? Yes, I can. Yes. I was gonna say, sometimes I just like build things with my little brother, my younger brother. We just like put together some bit of circuitry and moving a motor or things like that. So yeah, that's something that you learn and then you don't forget if you keep on doing, right? Like everything, really. Is it fun working with robots, and why? It is fun working with robots because let's take the example of Pepper. Because you can, what is interesting actually is whenever you have to program a robot to do something, you have to think about the way you would do it, okay? So for example, when I was programming the robotic arm to pick and place the object, I had to think about myself. How do I hold an object? And how do I recognize an object? Do I recognize it with the shape, with the color, with the texture? And how do I hold it from the top, from the side? Do I have to move my hand backwards? Would that be ideal? No, you have to do like this. So you kind of think about how you yourself would do something, okay? And then you have to teach the robot to do that. So it's like teaching a child. My sister used to see me like teaching my robot or programming my robot, and she used to have like a laugh saying, it's like your baby. Yeah, it is like my baby. So you kind of have to, and sometimes it throws you an error and you're like, no, you don't understand, you should do this, you shouldn't do that. So things like that. So it's quite fun. Do you spend a lot of time working? So well, it's a full-time job work, so you do like something like 37 hours a week. Yeah, that's the job. But like uni life, you don't have a number of hours you work every time basically. But so like my last year at uni, when I was working on the final project, I was in the lab every day. And I mean, you don't mind it though, because you are there because you like to be there. And yeah, so you're fine with it. How do you make the robots that go in the water? Do they have electrical parts? Yes, they do have electrical parts. So that's the thing. So whenever you want to design something and you want it to be, in this case, going underwater, or maybe other cases, you have to think about if it's, I don't know, a robot that has to go in the desert, you have to think about temperature. You have to think about humidity levels or whatever. And or for example, if you're building a robot that will fly or will climb mountains or whatever, you have to think about pressure. You have to still think about temperature as well. things like that. So for a robot underwater, for example, you will need to make sure that all the electrical parts are sealed in an enclosure, or because you don't have like a component that could go underwater, really, like bare component that would go underwater, because then we would like just crash, like not crash, but short your circuit. Okay, so it won't work. So you need to understand how design would work, and you need to design a solution for that to go underwater. How do you program robots? You just use a computer, you plugged in. So many robots, they would have a sort of interface, so they will have a cable. Mainly there are USB cables, but there are other kinds as well. And then you just plug into your computer and you open your IDE, like your interface for program, and you just type like in movies, and then run it, and then you will go through your robot, and then the robot will do something. When was the first robot invented? The first robot ever? This is actually a good question. I've never thought about it. I don't know. I heard someone saying that it's in Bristol, but I think it was a bit biased because we are in Bristol. I don't know. How do robots control themselves? So you have to make them control themselves. So you program them for with some sort of intelligence. And for example, if it has a sensor, let's take the robot that you saw in the video before, like the one that was following a line on the floor. So basically, we put a sensor. Okay, we put a sensor able to recognize the reflection of the light. Okay, so if it was on the white tape, I don't remember if it was white or, but anyway, if it was on the colored tape, okay, it would reflect the light differently than when it was on somewhere else on the floor. So when the robot finds the tape of this kind of color, whatever, then it will send an information to the robot, and then it will send an information to the microprocessor, which is like the brain of the robot, let's say. And then you will have to tell it, when you see the line, then do something, and then you program it to do something only when it sees the line, sorry. And when it doesn't, else do something else. So this is the way you give it some sort of intelligence, and then they can control themselves, sort of. How many female engineers are there at your work? This is a very good question. Not many, not many. Like every time I end up in a meeting or a training course or a seminar or whatever, I'm always the only one. So girls, please become engineers and come with me, and so we can like be together. It's not yet an ideal situation. So women in an engineering environment are still not even 50-50. So it's not an even percentage, but there are some, and they're really nice, and yeah, we get along well. So we still have some work to do. Can you make robots to help children to do their homework? Yes, this is an amazing idea. Help children to do the homework, not do the homework for the children, right? So this is a good idea, actually. You can have, there are some, not specifically for homeworks, but for supporting children, for example, that they sometimes they won't be able to go to school for many different reasons. probably medical reasons. So they have this kind of, you can look it up online. There is this kind of robot that will sit on the chair in the child's place in the classroom, and you will have this massive screen, okay? And the child at home, he will have a similar robot with another screen. So the child at home would be able to see his classroom or her classroom through the screen, through a camera basically, and the children in the classroom will see this child through the camera, through the screen. And so there's this kind of interaction for the child being at home, raising the hand, so the teacher can see him raising the hand, and this kind of it's helping children to study. Or sometimes, I mean, another robot to help with homework could be I don't know. You invent it and you tell me, and I'll listen to that. Are any of the robots transparent? Oh, I don't. I've never heard about, but it could well be. I know there was a robot was, I think, a bit translucent, not probably completely transparent, but a bit translucent, and it had the shape of like a snake, and it was moving like a snake because it was contracting some part of its body and releasing some others, and it was like moving like a snake basically, and it was transparent. I don't know why though. I remember this is the only one that I can recall really. Yeah. What's the biggest robot you've made? The biggest? And how do you get robots to move? The biggest robot I made, we tend to do like small robots, like the ones that I showed you before. Maybe like if you consider the robotic arm as just a robot, that is the biggest, because I don't think I've ever worked with anything bigger than that. And it was quite big because if you imagine your arm, it's not like that, it's bigger than that, because it has all the joints to be able to do all the maneuvers. So imagine, this is something actually interesting. Imagine your wrist, okay? You can move it like this, and you can move it like this, rotate it, and you can move it like this, okay? You can do many movements with your wrist. But if it was a robot, you would have one joint to do this, and then a link, and then another joint to do this, and then another joint to rotate it. It would be really difficult to have an entire, just one joint to do everything. So that's why sometimes the robots can be massive, okay, especially the industrial ones. Do you know how Cosmo, a toy robot, works? Yes, is Cosmo the one that is like a little cube that lifts things? I think is that is the one. How it works? Well, it's definitely, as every other robot, it's going to be programmed inside, okay? We'll have a microprocessor inside, and all the motors to move around, and yeah, so it's I don't know exactly how it works, but the principles are common to all the robotic systems. Can you build a robot dog? Yes. Well, I could, and in the sense that if I wanted, I would be sitting there and trying to figure out how it would. But other people, they did. If you Google what's it called, Boston Dynamics, you will see like a sort of dog, big, and they call it I think they call it black dog or big dog, and it makes jumps, and it has as a dog, it has 4 legs, okay? It looks a bit creepy if you look at it, just because it doesn't have a head. It doesn't, they only build like the frame for the 4 legs and the body of the dog. But look it up, it's quite impressive, the things that it does. How long does it take to program a robot? I'm gonna say again, it depends. So it's actually less than actually building a robot, or actually programming from scratch. Okay, if you have already a robot and have already a system, whenever you program it, you just send the signal and then to the robot to do whatever you want it to do, and that would be quite straightforward, especially if you already have the setup, you already know how to do it, then it's easy. Yeah, that's quite quickly done. How do you make the robots different colors? It's I've never done it before because we were not we've never been how do you say, we've never cared about the aspect of the robot, right? We just needed to be working. But you can change the color, you can do anything. I think industrially the way they do is like with sprays, like when they spray a car, for example. Yeah, that's how they do different colors, I think. Do you take your robots anywhere else around the country or the world? Yeah, you can take them anywhere you want. Yeah, it will depend. You will have to think about the conditions of wherever you go. Like if you need the power, or if you need, or for example, environmental conditions. If it's really hot and you don't have aircon, you really need to think about all the components inside your robot. They shouldn't be overheated, otherwise they will just poof, break. And or on the other side, if it's freezing cold, you have to think about it, so you have to take precautions. Yeah, I think this is it.
I think that is it.
Yeah.
Wonderful. Thanks, Miriam, once again.
Thank you.
Again, a brilliant presentation. Some great questions.
Yeah, great, good questions.
And it depends, but I think there's some quite good answers too. It depends, you know.
I can't say. Sometimes it's like I really want to say something, but it really depends.
I know. Okay, so thank you, everybody. Thank you, Davin and Ignatius.
Thank you.
I think it's only you've left. I'm going to close down the meeting now. We've got over 10 minutes over the time. Thank you all very much, and we'll speak again soon. And I'll send you an email shortly, Miriam. Okay.
Yeah. Fantastic.
So goodbye, everybody. Thank you very much.
Bye bye.